Let's look at some problems with the simple pendulum. So here is the formula you're going to need, where t is equal to the period is equal to 2 pi times the square root of the length of the string over acceleration due to gravity. So let's look at what we're trying to do here. Find the length of a pendulum string, I assume I mean the string, that has a frequency of 0.5 hertz. Okay, so to find the frequency, that's just the inverse of this, because period is equal to 1 over frequency. So the inverse of this here equation is going to be, here frequency is equal to 1 over 2 pi times the square root of acceleration due to gravity over length. And we know g is just 9.81 meters per second squared. Right, okay. So we have a bunch of values. The only thing we're missing is the length of the string. So let's go ahead and plug and play. So our frequency is 0.5 hertz, and that's going to be equal to 1 over 2 pi times the square root of 9.81 meters per second squared over L. So we need to solve for length. Let's rearrange the equation. Let's multiply both sides by 2 pi so we can get rid of this. So we have 2 pi times 0.5 hertz is equal to square root 9.81 meters per second squared. I'm including the units at each step just so we don't get lost here. Not that it's going to be easy to get lost, but it's a good habit to include your units with each step. You know, in case you're doing something a little bit more complex, including the units will help you keep track of where you're at and what you're doing. So next we're going to square both sides to get rid of the radical. Squared. And that's going to give us 4 pi squared times 0.25 is equal to 9.81 meters per second squared over L. And now we just separate the L. We can just switch these two quantities here. So we have L is equal to 9.81 meters per second squared over 4 pi squared times 0.25 hertz. And if you have a calculator, go ahead and type this in, and you'll see that L is equal to 0.99 meters. And that's our answer. Let's do one that's a little bit harder. So we have a pendulum that has a bob with a mass of 4 grams. It's observed to have completed 60 cycles in 42 seconds. We need to find the frequency, the period, and the length of the string. So the number of cycles, which we'll call n, in a specific amount of time is defined as the frequency of an oscillatory system. So that just means frequency can be just thought of as the number of cycles over a certain amount of time. So we can calculate the frequency pretty easily. We have 60 cycles over 42 seconds, and that's going to be 1.43 hertz. So now we have the frequency, and the inverse of this, which is the period, is going to be 1 over 1.43 hertz, and that's going to equal about 0.699 seconds. So 7 seconds. So now we have the frequency and the period. Now let's find the length of the string. And just like before, we'll use this equation. Frequency is equal to 1 over 2 pi times square root acceleration due to gravity over the length of the string. And we have all the parts we need, so let's just go ahead and fill it out. We have F is 1.43 hertz, and that's equal to 1 over 2 pi times 9.81 meters per second squared over length. So we just did this, but we can run through it again. Let's go ahead and multiply both sides by 2 pi, and we can square both sides to get rid of the radical. So we'll go over here, 2 pi times 1.43 hertz squared is equal to 9.81 meters per second squared over L. And now we can solve for L. L is equal to 9.81 meters per second squared over 4 pi squared times 2.0445 hertz. And if you type that into a calculator, you'll find that the length will be about 0.1215 meters. And that's our answer. Let's go ahead and do one more. A pendulum has a period of 1.4 seconds on Earth. What is the frequency on Mars, where the acceleration due to gravity is 38% of that on Earth? And let's go ahead and find length and period too. We might as well. So first, let's find the length of the string. So on Earth, well, let's see. Let's use this equation. T is equal to 2 pi times the square root of length over acceleration due to gravity. So we know the period is 1.4 seconds equals 2 pi times square root length over 9.81 meters per second squared. I don't know why I put that in parentheses. And if we run through that, we'll find that length is going to just be equal to about 0.49 meters. And the reason I did that was because the length of the string is not going to change just because we are on a different planet. So we might as well get a different variable here so that we can make things a little bit easier on ourselves. So for Mars, the acceleration due to gravity is 38%. So 38% of 9.81, and you can do that just by multiplying 9.81 times 0.38, and that's going to give us about 3.73 meters per second squared. So that's our new G, our G for Mars. So now we need to find our new period on Mars. So we'll use this equation again. T is equal to 2 pi times square root length over G, and then we can just plug in our values. So T is equal to 2 pi square root 0.49 meters over 3.73 meters per second squared, and that's going to give us 2.28 seconds. And then, of course, frequency, being that frequency is just 1 over t, frequency is just going to be 1 over 2.28 seconds. And that's going to give us 0.44 hertz. All right. So that's it for the pendulums. We just went over some simple problems. Keep practicing. It really just becomes second nature once you get the formulas down. They get a little bit more complicated with angles and all that stuff, and I might go over that in a future video. But in the meantime, thanks for watching, and I'll see you next time.